Now, tell me, what are these?
Flowers.
Real flowers?
Yes.
How long are they?
About 8 or 9 inches.
What do they weigh?
2 ounces.
Good. What kind of flowers are they?
Ooh! Well, that one's a rose.
And the other one?
Carnation.
Right. Now, what colour are they?
Don't be silly.
That's the first thing about colour. In the dark, it doesn't exist. So what is colour? What are colours? The colours you see now, in fact any colours, are the result of light acting on the eye, the nervous system, and the brain. The most colourful part of the eye is named from the old Greek word for rainbow, the purest colour range in nature. And the name iris was applied to the prismatic spectrum, the purest colour range engineered by man. There was no real science of colour until Newton showed that white light is a combination of all the colours of the visible spectrum. Later, the wave theory of light suggested that each colour in the spectrum corresponded to a different frequency. What we call light, and what we see as colour, is the range of frequencies to which our eyes are sensitive. But this is a comparatively narrow band of the entire spectrum. Our eyes will not respond to infrared radiation, but it is possible to convert it to frequencies which are visible. So it is with radio waves. We cannot receive these directly, but we can use them to generate other frequencies as visible light. But what about the colours within the spectrum? No browns, no greys, no purples. For these are hybrid colours produced by a mixture of wavelengths. If we take only 3 colours of the spectrum, green, red, and blue, we can combine them as coloured light to produce other colours. By varying the intensity, we can in fact produce any colour sensation we like. This is additive colour mixing, adding coloured light to coloured light. But the painter in the picture is using subtractive colour mixing. Each of his pigments absorbs certain frequencies. As he mixes them, he is subtracting more and more frequencies from the entire spectrum. The frequencies that remain are reflected as a different colour. Why 3 primary colours? The answer lies in our heads, but we don't know what it is. We know that the cones of the retina respond to 3 different parts of the spectrum. But how complex the mechanism that interprets their signals? For the trained eye and mind can distinguish over 1 million shades of colour and match them precisely. Think what's involved in matching a given colour. It involves 3 separate factors. What colour is it? What shade of that colour is it? How bright is it? And the relationship will vary from each colour to the next. Yet the eye can give us a perfect match. So here we are. Thanks to a few pounds of jelly in our heads, we can discriminate and appreciate all the intricacy of a coloured world. But why? Why coloured? There are so many types of colour in the natural world. There are colours that exist for no particular reason, an accident of structure, but still basic to our experience. Then there are colours with a purpose, the colours of deception, of camouflage. For protection against attack, or for cover in stalking a prey. The outcome of countless generations of evolution. Some may seem ineffective to us, but they evolved to deceive other eyes than ours. Then there is the reverse, colour for identification, for attraction, so that one of a species may recognize another, may signal his intentions to a mate. Already, we have the idea of colour as language. Not all these colours are produced by pigmentation. Some are caused by the refraction or diffraction of light from the structure of feathers and wing scales. The colours of identity, some real, some bluff, so that this poisonous butterfly is mimicked by this harmless one, and even by this non-poisonous moth. Among the most brilliant colours in nature are the colours of attraction, like the ones that entice the butterfly and the bee. And into this world of teeming colour with its attractions and warnings, its camouflages and disguises, comes man. Man the talker, with a need to describe his sensations. It seems that even the simplest languages have words for black and white. Where there is a third colour word, it will be red. And where there is a fourth, it will be green or blue, the primaries again. A complex language like ours has many colour words. Even so, we are driven to name our colours after things. All these and many more have given us names for colours or shades. Yet we are still sloppy in our use of colour words. We call this cat a blue, this horse a grey, and this dog red. Both these drinks are white. We call the red end of the spectrum hot, even though the hottest flames are blue. We use colour words to describe other sensations. What do we mean by tone colour in music? For that matter, why is this music called a blues? We use the word blue for melancholy, green for inexperience, yellow for cowardice. Colour for expression and symbolism. Under the Byzantine Empire, colour was used as a way of presenting social or emotional or spiritual information. In the West, a similar process of symbolism took place. In the Middle Ages, an adept might have read the colours of a painting as we do the words of a book. Blue, for example, represented heavenly love, while brown symbolized spiritual death. With the Renaissance came a change to what might seem realism. But this was symbolism too, in a more subtle form. These colours are not realistic because the artist was using them for emotional effect. With time, our acceptance of colour has become more tolerant. We can claim to read colour with more imagination and perception. For the whole of his existence, man has been making coloured images and has ransacked the earth for his materials. Lead, zinc, and heavy spar for the whites. For the yellows, hematite, cadmium, barium, the bark of the oak, and the urine of Indian cows fed on mango leaves. Lapis lazuli, tin, the foliage of the indigo shrub, for blues. Cinnabar, the root of the madder plant, the bodies of female insects, for the reds. For the purples, the flesh of mollusks. To these he has added oils and resins, waxes and gums, glycerin, honey and eggs to soften and to stick. But man hasn't limited himself just to recording the colours of nature. He's been called a tinkering animal, and it's certainly true of his attitude to nature. There's his endless search for the hybrids of orchids, the quest for the black tulip, the blue rose. The fact is, we enjoy changing the colour of things, and when we can't do it from within, we do it from without. We call this fashion, and it's peculiar to man. The peacock's display will never fail to attract the peahen. But we commit ourselves every year or every season to a rethink of what is attractive. Fashion raises another point about colour. What colours clash? What colours tone? And is this merely a question of taste, or something quite fundamental to our vision and intellect? It applies to everything we colour, and we colour virtually everything we make. Over the centuries, we have found and refound ways of colouring pottery with fire-hard glazes. We've devised fluxes for fusing our images onto metal. And from the very invention of glass, we have coloured it. Because it allows the direct passage of light, glass is capable of the purest colour effects. But what of today? For our age is the most colourful and highly coloured of all. Where do our colours come from? Certainly not from the bodies of insects and the bark of rare trees. The making of colour has become both an exact science and a major industry. The first wholly synthetic dye was produced only in the middle of the last century, but such is our thirst for more colour and more lasting colour that today the dyestuffs industry produces an almost infinite range of shades with a high degree of fastness. And the science of colouring is changing. Now we can make dyes that don't merely cling to a fabric, but form a chemical bond with the fibres to last as long as the fabric itself. Techniques are changing too. This is polychromatic dyeing, where several colours can be applied to a fabric at the same time, with the movement of the nozzles producing a preset design. We can apply colour to finished materials, as with dyestuffs and paint, or we can begin with coloured materials and shape them to our needs. The advent of plastics has allowed us to combine permanent colour and shape in a totally new way. Today, with such a wealth of dyes and pigments available, the problems of colour matching have become increasingly complex. We now have computers programmed to do it for us. They can analyse a sample and draw on their banks of information to produce a matching combination of colours. But it's comforting to know that for all the computer's speed and accuracy, the final judge is the human eye. The computer can analyze these colors, but it won't come up with the word beauty. It can't tell us why this is important. It can't describe the smell of this, or give our palate a foretaste of this. And what computer could analyze the sensation of these colors? Only the computer within our heads. In the end, an appreciation of the color of beauty and the beauty of color lies within ourselves.